Hey Olivia, here's another problem that you gave to me, and this one's a little bit tricky on a few levels. One way that this is kind of tricky is that this is a triple angle, and the other thing that's kind of tricky is that you're dealing with secant. So whenever you're not dealing with sine or cosine, things get a little trickier. So, but just like the first problem that you gave to me, what we want to do is first isolate the trig function secant, even though it's a triple angle, that's something we'll deal with in a minute, but we need to isolate secant. So I'm dividing both sides by 2, and then what I get is the equation that the triple angle of secant equals 2. So our first step of complication is to recognize that secant, and this is just really from your memory, is secant is reciprocal to cosine. So remember that if you say secant of x, it equals the same thing as 1 over cosine of x. So what this means is that I'm just simply gonna go cosine of 3x equals. Now, what I just said here is that the functions are reciprocal functions, which means that cosine of 3x equals the reciprocal of 2. And 2 is 2 over 1. So when you take the reciprocal, you get 1/2. Okay, so that was the first tricky part. And now what we need to do is continue solving this equation. So remembering some of those angles in the first quadrant, that's that's something that if you've got a few of these angles down, then they sort of pop out at you. Um, this is asking for radians, so I'm going to talk radians instead of degrees. So I would have said 60 degrees, but pi over 3 radians is what they're looking for over here. They're asking for radians when it says 0 to 2 pi. So if I have an angle of pi over 3 on the unit circle, then what I get here is 1/2 comma root 3 over 2. So since we're talking cosine, not sine, we're interested in the first of the ordered pairs. Okay. So here's the thing is that, this tells us that cosine of pi over 3 equals 1/2. However, look at the angle that was given to us. So I'm just going to box this up here. It's a triple angle. And this right here is saying, sure, cosine of pi over 3 equals 1/2. However, this is saying cosine of 3x. So basically, these two have to equal each other. Okay, so the input into the cosine function, if it's 3x, has to equal the input of pi over 3 is the idea. So the input has to equal the appropriate input of pi over 3. Okay, but don't forget that also any rotation of any multiple of 2 pi will also give you the same answer. So 3x equals pi over 3 plus 2k pi. So what we do is we do need to solve for x. So it says solve on 0 to 2 pi. What we do need to do is solve for x. So I'm going to multiply both sides by a third in order to solve for x. So I'm going to take this side here and multiply by a third. Well, that's going to allow us to cancel and get our plain old x. So x equals, and then we distribute this through, you have pi over 9 plus, and then you have your 2k pi over 3. Okay, kind of complicated. However, understanding that k stands for any integer. And so if k stands for any integer, then I just start numbering them up. Suppose k equals 0, then our answer would be x equals pi over 9. Okay, what if k was 1? Then it would read pi over 9 plus, and then you'd have 2 pi over 9. Okay, so over 3, pardon me. Okay, so now what we need to do is find the common denominator of 9. So I'm going to have to multiply top and bottom by 3 to get that. And looks like then we're going to come up with another solution here. So I have this plus, and then notice that that's 6 pi over 9. And I get 7 pi over 9. Now that is before 2 pi. So it says give all the answers between 0 and 2 pi, and I am still between 0 and 2 pi. Notice that when I talk about over 9, that this would be 18 pi over 9. So certainly 7 pi over 9 is well before 18 pi over 9. So now I've got a growing list here. So my x could be pi over 9, my x could be 7 pi over 9, and I'm going to do this again. What if k was 2? Then I would have pi over 9 plus, and then I would have 2 times, now my k is 2, times pi over 3. Okay, so that would be pi over 9 plus, and then you've got 4 pi over 3. All right, but we need to multiply top and bottom by 3. So we'd have 12 pi plus 1 pi is 13 pi over 9. And again, comparing that to the 18 pi over 9, I'm well before the 18 pi over 9 at 13 pi over 9. So that's yet another answer. Now if I did this again, if I said k is 3, I would be over the top. So here's my 3 answers from doing this, but guess what? There's more. Let's go back to what we were saying before about 3x having to match up with pi over 3. Okay, that was good, but also x is positive in the 4th quadrant. So I'm going to come down here, I'm going to make a reference angle here of pi over 3, and then I ask myself, all right, if that is the case, then what's that angle? Okay, the standard angle here would be 2 pi subtract pi over 3. So that angle would be what? Well, this is times 3 times 3. I get 6 minus 1 is 5. So I have 5 pi over 3. All right, so I'm going to go back to this statement here, and what this says is that also cosine of 5 pi over 3 also equals 1/2. And just like before, we said that this has to match up with this, and so therefore they're equal to each other. So I'm just going to do just like before, that this yields the equation that 3x equals, now instead of pi over 3, I'll use 5 pi over 3 plus 2k pi. Okay, again, we multiply both sides by a third to isolate the x. And what we have then is x equals 5 pi over 9 plus 2k pi over 3 when I distribute that 1/3 through. Okay, so just like before, what we're going to do is let k equal to 0. So in this equation, we want to do k equals 0, k equals 1, and k equals 2. All right, and then that gives us 3 more x values. So notice that we've got 1, 2, 3 x values here, and what we need is 3 more. So I'm kind of running out of room, so I got to erase this stuff off. And come down here. Okay, and let's start with k equals 0. And here we go. So if k equals 0, then we have x equals 5 pi over 3. Again, all I'm doing is I'm just plugging in k equals 0 into now this one. Okay. Not 5 pi over 3. Just lost track here. Sorry, it's over 9. All right. So 9. Okay. And so what would happen if we said that k equals 1? Then it would be x equals, and you have 5 pi over 9 plus, and now it's going to be 2 times 1, which is 2, and you would have 2 pi over 3. Finding a common denominator means we multiply top and bottom by 3. This is 6 pi plus 5 pi, it's 11 pi over 9. Now this is well before my 18 pi over 9, so I'll save that answer. So we've got this equals x. And the last x is going to come about by saying, what if k is 2? So I would have x equals, you have your 5 pi over 9 plus, and here we would have 2 times 2 is 4, so I would have 4 pi over 3, but finding the common denominator, that would make 12 pi over 3, and 12 plus 5 is 17. So I would have 17 pi over 9 equals x. Okay, that is before 18 pi over 9, right? So I have actually 6 solutions. 1, 2, 3, 4, 5, 6. And I've captured all of the solutions to this equation. All right, Olivia, I hope this was helpful, and let's talk later.